Greetings, I'm Ms. Kingsley, and this video is about problem solving. It's a continuation of the work on numerical patterns. It is for 5th grade from the Go Math materials, and it is from lesson 9.6 in the practice materials that are available both online and possibly in paper. So we're going to spend some time here on this practice problem, and the idea here is that you can pause the video and see if you can figure out answers on your own first if you don't have the actual material to work on, and then I will be showing you how it goes. Okay, those of you that did 9.5, I think you're going to find 9.6 a little bit easier. 9.5 was a little rough going there, huh? Okay, so up at the top, let's just notice it says problem solving, find a rule. And I like to say, look for a pattern. Okay, so it gives us the answer to this first one. This is intended as like homework practice, but I'm just going to talk through it so you see why that's the answer. Faye buys 15 t-shirts, which are on sale for $3 each. How much money does Faye spend? They mean how much money does she spend altogether? So we would look for the total amount that she spends, and we're looking for this number right there. When she buys 15 t-shirts, which is her total number, how much is she going to spend? So this is where we're looking for a rule, trying to find a rule or looking for a pattern. And the pattern is between this row of numbers, as the number of t-shirts is given, what happens to the amount spent, and assume that the rule continues. So when they start with a 1, it's pretty easy, especially if we're going to try multiplication first. So we would say 1 times what number, some unknown number, equals 3. Well, then we can see that that number is 3. And so as you see, their possible rule is multiply the number of t-shirts by 3. So let's see if it works. 1 times 3 is 3. That works. 2 times 3 is 6. 3 times 3 is 9. So we have this working in all 3 cases here. So to find this total amount, we would apply that same rule, which is times 3 of the top number, and we would say 15 times 3. Work that out, and we get the answer they gave us, 45. 45 what? $45, because the question is how much money does Faye spend? Okay, so let's go on to do one where they don't give us the answer. Here we go. The Gilman family joins a fitness center. They pay $35 per month. That per is an important word there. So that means each month they're paying for $35. By the 12th month, how much money will the Gilman family have spent? So we're talking about dollars, and we're looking at the 12th month, which is over here. So once again, we're looking for a rule between this top row of numbers and this bottom row of numbers. So again, they gave us a 1, which makes it even easier than some of our prior problems. So we're going to say 1 times what number equals 35? Well, we know by the identity property as above that any number times 1 is itself. So this is 35. So our possible rule here is to multiply the number of what? Are you paying attention? Are you watching? Number of months by, and what are we multiplying it by? Say it out loud. Yes, 35. Okay, so to find out how much they will have spent after 12 months, we're going to have to do some multiplication here. So let's do 12 times 35. So you can do that the old school way, the traditional way. I'm going to go ahead and show it with the area model or partial products. So we would draw our model here. We would have 30, 5, and 10 here, and 2 are expanded form of our numbers. or the other way around, it's fine, either way. You can put your one factor here, one factor there in expanded form. We're going to multiply out 10 times 30. We go 1 times 3 is 3, 2 zeros, so we have 300, excuse me. 10 times 5, I think we all know that, it's 50. 2 times 30, 2 times 3 is 6, add my 0 for 60, and 2 times 5 is 10. Then we're going to add these up, 300 plus 50 plus 60 plus 10, and we're going to get 0 in the ones place. 5 plus 6 is 11, plus 1 is 12. Carry the 1, and we have 420. Okay, here's to see if you remember. 420 what? 420 what do we have? That's right, dollars. Okay, just gonna adjust that screen a little bit. Okay, let's go on to the next one. Here we have, I'll be right with you. Let's do this one. Okay, Hetty is stacking paper cups. Each stack of 15 cups is 6 inches high. What is the total height of 10 stacks? So when they say total and we have a chart like this, then we're going to go to our largest number and we're trying to figure out what is this missing number. So again, we're looking for a rule. And again, they give us one that starts with a 1. So 1 times what unknown number equals 6. And then we're going to see if our rule works. So 1 times with our identity property, 1 times any number is itself. So this is 6. So this time, let's check to make sure it works. I didn't do that up above with 35, but it did work if you just take my word for it. Okay, so let's go. 1 times 6 is 6. 2 times 6 is, yes, 12. So it works here, it works here. 3 times 6 is 18. So we're happy with our rule. So our possible rule is multiply the number of, what is this? Stacks of paper cups. The number of stacks by 6. Okay, well, they gave us an easy multiplication problem here. 10 times 6, we don't even have to work that one out. I know that you guys know that one. And that is 60. So we have 60. Now we have to figure out 60 what? What are we talking about here? We're talking about the total height, how high the stack of cups is, and it's measured in inches. So we would label this, and labeling is really important, inches, abbreviated like that. Okay? So let's go on and do the last one. I'm not going to do the spiral check on these. So for, you could do them for practice and check to see how you're doing, but we're going to continue with this, just the lesson problems. Okay, this says lesson check, and when I did this, I really decided this should say lesson continued, because these problems are different than the problems we just did. I find them quite fun, but we'll have to see what how to do it. So this says, how many squares are needed to make the 8th figure in the pattern? Okay, this is figure 1, this is figure 2, this is figure 3. They want to know how many squares are going to be in this figure way out here, number 8. Well, to do that, we have to figure out what is happening each time we go to the next figure. So can you see that in figure 1, we just have 1 square. In figure 2, we have that square and we add 2 squares to it. Pause the camera, see if you can see it in the next one. Okay, then come back. Okay, what's happening in figure 3? Well, they took figure 2, which is right there. Now we're looking at this part here, and they replaced and they added 1 square to each side. So they're adding 2 squares to each figure. Okay, so we could say our rule is, or our possible rule is, add 2 squares to each figure. Now, I could draw this, keep going and draw them, but that would take a lot of time and you'd have to be really careful that you kept drawing these figures. But let's go back to our charts that have rules. So I'm going to make a chart here that has 2 rows. Okay, and one row is the number of the figure, such as 1, 2, 3, 4, up to 8. And the next row is the number of squares. You see what I'm doing? So I'm just taking this and creating a chart which is going to show us that pattern. So my first one is 1, and I get 1 down here. And my next one is 2, and I get 3 squares, because I'm taking this number and adding 2 to it. So this time our whole pattern is going horizontal. It just has to do with what's happening with this row. So our pattern here is +2. We go to our third figure and we +2 and we get 5. Let's keep going until we get to 8. 4, 5, 6, 7, 8. I don't have to draw it all out. I know how many squares are going to be there. So we're going to go +2 is 7, +2 is 9, +2 is 11, +2 is 13, +2 is 15. So the answer to my problem is going to be 15. How many squares are needed to make the 8th figure in the pattern? 15 squares. Again, looking for patterns. Are we multiplying? Are we adding? Do we care about a relationship between 2 rows, or the relationship as we move from one number to the next in the rows? Okay, let's see if we can figure out number 2 here. Again, if you can, pause the video and do some thinking on your own if you haven't already done this problem. So, what expression could describe the number of squares in the next figure in the pattern? So it has 2 squares, 5 squares, 8 squares. So we're going to take a look at what happens again. I'm going to draw another chart. Okay. So I have my figure number on top, figure number, and I have the number of squares on the bottom. And let's see what's happening. We have figure 1, and we're going to just count our squares. We have 2 squares. Now we have figure 2, and we have 1, 2, 3, 4, 5 squares. Now I have figure 3, and I have 8 squares. Can I figure out what's happening? Again, you could look carefully at this figure and see what did they do to this figure to get this next one. Well, it's complicated, and we can see down here. Let's think about it. What happened to get from here to here? Are we multiplying or adding? Hard to see any multiplying pattern going from the top to the bottom row, so I'm going for the adding idea again. And if you can see that, say it out loud. What are we adding to 2 to get 5? And then again from 5 to get 8. That's right, we're adding 3. So each time we are adding 3. This is much harder to see and where they added the 3. But I'm going to take this figure and find it over in figure 3. So I'm going to start down here because that's my little leg. Go out like this. go over. And you can see that what they added each time is 1, 2, 3. And if I did the same thing and found my figure in here, they added, here's my original figure, figure 1, and there they added 1, 2, 3 to get to figure 2. In this particular case, I find it easier to find the pattern in the chart than to find it in the picture. And on this one, I found it easier to find it in the picture. Your brain might work differently. So we all have to use whatever it makes most sense for us for finding these rules. Okay, so that is the end of this lesson for today. I hope that was helpful. And again, remember, as much as possible with these videos, pause them, try to do some work on your own, and then see how you do. And it's totally fine to make mistakes. As you know, I've said in the past, mistakes always make us smarter. I'll see you next time. Bye-bye.